Very good morning, friends. Myself, Dr. M.H. Annaya, and in today's video, we have a numerical example on an infinite steel plate which is subjected to a pull, and this plate has an elliptical cutout whose dimensions are given, and we have been asked to find out what is the value of stress concentration factor when the major axis of the elliptical cutout is normal to the load axis, and in the second case when it is parallel to the load axis. So friends, we will just write down the sketch for this problem. An infinite plate with an elliptical cutout having major dia 50 mm and minor dia 20 mm. We have a plate here, and friends, is infinite plate, and it has an elliptical cutout. That is, we will write an ellipse somewhere here, and this ellipse has got the dimension major axis as 50 millimeter, and the minor axis of that cutout is 25 millimeter, and this is subjected to a pull, that is F is some value of the load F. Friend, if you refer to the machine design data handbook, there is a sketch of the plate with the elliptical cutout with the major axis normal to F and major axis parallel to F. There are two cases. So we will call this as case A. Case A, when the axis of the major axis of the ellipse is perpendicular to F. And let's see, if you refer to the data handbook, they say stress concentration factor for an elliptical cutout with major axis normal to load F is given by K sigma is equal to 1 plus twice A by B. Friends, this is available in machine design data handbook. This is for the part 1. The major axis of ellipse is normal to F, and this is the formula. Then we will know what are these A and B. Friends, here A is major axis by 2 or half of major axis. That is major dia, whatever major axis or major dia. That is half of the major axis of that is 50. That works out to 25 millimeter. And small b is half of minor dia or minor axis, minor dia or minor axis, which is half of 25, that is 12.5. So friends, if you substitute the value of A as 25 and B as 12.5, we will be able to get what is K sigma, the stress concentration factor. Friends, we will take up this and we will write down here 1 plus 2 times A value 25, B value 12.5. The value of K sigma works out to 1 plus twice 2, that is equal to 5. So friends, when the major axis is normal to the load, we get K sigma equal to 5. And on the same lines, let us work out the value of this K sigma when the major axis of ellipse is parallel to F. So I'll write down this sketch showing the elliptical hole being parallel to the applied load. So they will be acting in this direction, F and F, and this is the axis, and this is measuring 50 mm, that is twice A is 50. The minor axis measures 25 mm. Now friends, for this case, when the major axis is parallel to F, we have this formula K sigma is equal to 1 plus twice B by A. Friends, this is 1 plus twice. What is B? B is half of minor axis, that is 12.5. Already we have calculated, and this A is half of major axis, that is 25. Friend, this works out to 1 plus this is 1, that is equal to 2. Therefore, when the major axis of the elliptical hole is parallel to the load axis, we get K sigma is equal to 2. Whereas in the first case, when it was normal to the load axis, we got the value 5. Friends, I hope the presentation was interesting, and if you like this video, do share this with all your friends. Have a nice day.